right, now let's look at autorhythmic cells. So autorhythmic. Autorhythmic cells are 1% of cardiac cells. And they function to initiate the action potential, which causes a heartbeat. So they initiate the action potential. So autorhythmic cells begin their cycle at negative 60 millivolts. So they begin the cycle at negative 60 millivolts. So that's right here. And they start to depolarize immediately. I don't want to use that color. Come on. Sorry, let's use another color for that. So they start to depolarize very slowly. And they do this because of special channels they have called IF channels. And these are leaky channels for sodium and potassium, but mostly sodium. And as sodium is coming in, leaking in, and potassium is leaking out, the membrane is depolarizing slowly. Once it gets to negative 40, it will depolarize. Boom. So negative 40 is the threshold. So autorhythmic cells have a threshold, but they do not have a resting membrane potential because they're always going, they're always depolarizing. So this area here of depolarization, this slow movement towards threshold, is called the pacemaker potential. And again, once it gets to negative 40, it's going to depolarize. So how does it do that? When we think of an action potential and you think depolarization, you're more than likely thinking of the opening of voltage-gated sodium channels. But that doesn't happen here in autorhythmic cells. The channels that are opened are voltage-gated calcium channels. So calcium moves in and depolarizes the membrane. Once we get to 20, then the membrane starts to repolarize. And how does that happen? Like you might think, voltage-gated potassium channels open. Potassium flows out and repolarization occurs. And it goes all the way down to that negative 60 number. And then once it gets to negative 60 millivolts, do we go to resting? No, there is no resting. So it starts up again. and climbs towards -40. And then once it gets to -40, we have an action potential. So this area here, from here to here, this positive 20 millivolt area, this 20 millivolt cytoplasm so 20 millivolt cytoplasm passes through gap junctions. In contractile cells. And that's what causes the contractile cells, so that's what tells the contractile cells to depolarize. So again, this is just 1% of cells, these autorhythmic cells, and they provide the pace of the heart. So they provide the pace of heart rate. Okay, so we'll look in the next video. We'll look at how that happens, how the heart rate, how the autorhythmic cells can increase and decrease the heart rate, and what creates your resting heart rate, normal heart rate.